Okay, so now we'll move on to the next exercise. Let's exercise 4E. First, we'll write down the topic integrating inverse trigonometric and hyperbolic functions. Integrating inverse trigonometric and hyperbolic functions. Okay, and then we'll do question number exercise 4E, question number 1. Look at this. Question number 1 part A. Show that integration of r sin x dx equals to, so they have given you. Now you all know that we know, now did we learn in all these rules how to integrate r sin x? We know how to differentiate r sin x, right? We don't know how to integrate. Okay, so if you take a look at all the rules that we did earlier, take a look at the rules. Okay, so integration of r sin. So I have taken the rules here. You can see we know how to integrate this particular person and get r sin x. We know how to differentiate r sin x. Look at this. We know how to differentiate r sin x, but we did not learn anywhere how to integrate r sin x. So now you might be thinking, is it very difficult? Actually, no, it's not at all difficult. What we do here is we use actually the product rule. So what's the product rule? Sorry, not the product rule. We use integration by parts. So how does the integration by parts rule work? U v dash integration is equal to what? U v minus integration v u dash. So you know what we do here to do r sin x. Now you know we know very well how to differentiate r sin x, right? So what I do here is for r sin x, now I know how to differentiate. So what I'll do here is I'll input a 1 here. This is a trick that we use in P4 for integration of ln x also. A similar method is used for the integration of ln x in P4. Okay, so what we do here is this 1, we take it as a v dash because v dash is the person we integrate, and we can integrate 1, right? And r sin x can be a u. Why am I doing like this? Because we know how to integrate r sin x. Sorry, differentiate. So then my u is r sin x. Look, my u is r sin x. So my u dash differentiation of r sin x is what? 1 over root 1 plus x square. You with me? 1 over root 1 plus x square. Then my v dash is 1, which means v dash to v, we integrate. So when you integrate 1, we get what? We get x. So all you have to do now is to input these values into the equation. So integration of 1 times r sin x. So what do we get? u is r sin x. v is x into x. uv minus integration v is again x, u dash. U dash is 1 over root 1 plus x square. You with me? So I get here x times r sin x minus integration of x over root 1 plus x square times dx. Are you okay with it? Okay, so now what do we do? Now this integration part is done. I need to finish off this to do this. So this is what we've been discussing since the beginning, right? These kinds of integration. So what rule are we using here? No, we can't use any of those rules when there is x in the numerator. We have used the basic rule in P4, f dash x, fx to the power n. So x times this is 1 plus x square to the power, I'm taking it up to the power minus half. Can you see? So we get here x times r sin x minus integration. So before I go to integrate, now do I have the perfect f dash x here? So this is my fx. What is the perfect f dash x? 1 plus x square differentiation is 2x. I need to put a half outside here. So I get here half times. So when we integrate 1 plus x square to the power minus half plus 1 is half. Divide by half. And we are completely done with the integration. So half to half can also cancel, right? xr sin x, the half cancels here. I get 1 plus x square to the power half plus c. So is this to show that xr sin x minus root 1 plus x square plus c. Do you see? Next one. Evaluate r sin x dx from 0 to 1, giving you answer to three significant figures. So the same thing they have just given us what? Limits. So limits are from where to where? The limits are from 0 to 1. Input the limits from 0 to 1. So when you input the limits, what happens? This guy, you have to give the limits from 0 to 1, right? Because we already have the integration. There's no need to put the plus half when you're putting the limits. So input 1 and 0. 1 times r sine 1. 1 plus 1 square is 2 to the power half, right? Are you with me? Minus, then replace this with 0. I get here 0. 0 into r sine, anything is 0. Minus, here I get 1 plus 0 to the power half. So they asked to get the answer to three significant figures. Tell me the answer to three significant figures. What is the answer for three significant figures? Okay, so the answer is 0. You can type, they want the answer to three significant figures, type it directly in the cal. It's 0.467, right? To correct the three significant figures. Move on to part C now. In part C, they say using the substitution u equal to x plus 1 and the result in a or otherwise, find the integration of r sine 2x plus 1. Okay. So how do I find the integration of r sine 2x plus 1? So basically, if you have r sine, now r sine 2x plus 1, part C, okay, integration of r sine 2x plus 1. Okay, how do you think this will work? So when you integrate r sine 2x plus 1, how do you think the rule will work? So in r sine 2x plus 1, basically we can use the same rule. The x is all replaced by 2x plus 1. All these x values need to be replaced by 2x plus 1. However, there is one small thing, because you have a coefficient of x. We have a ax plus b. So when you have a ax, the integration, we need to have a 1 over a. So this whole thing needs to have a 1 over 2 in front of it. So let's input the answer. I get here 1 over 2. Just put half in front of the whole thing. Put a big bracket and write x is 2x plus 1 times r sine 2x plus 1 minus 1 plus x square. 2x plus 1 square. Whole thing to the power half. And yeah, plus c. You can put the plus c outside. So half times 2x plus 1. We can simplify it a little bit. They have asked us. So 2x plus 1 whole thing square is 4x square plus 4x plus 1, and the other plus 1 gives you plus 2. And we can leave it at this point. We can't simplify any further. So you can leave it like this. So this is the answer for part C. So question number 4, show that the integration of r tan x dx equals to this. Shall we do this? It's 5 marks. Can you see? So let's show the integration of r tan x. Integration of arc tan x dx. Let's get the rules first and start doing. So again, you can see here arc tan x. You can see we do not know how to integrate arc tan x. Can you see? So then we know how to what? D by dx of arc tan x, which means what? We know how to differentiate arc tan x. So once again, the rule that we use here is we think of the one here and we take the one as the person that we will integrate, v dash, and the arc tan x is a u. So right now u is arc tan x, u dash arc tan x differentiation is 1 over 1 plus x square. V dash is equal to 1, v is equal to integration of 1 is x. Then let's substitute in 1 arctan x gives us uv minus vu dash, right? So what is u? Tan x with respect to x. uv. So u is arctan x into v is x minus integration v is x into u dash is 1 over 1 plus x square. Do you agree with me? So I get here x times arctan x minus integration x over 1 plus x square. Is that okay? So this part to integrate x over 1 plus x square, what is the rule that we need to use? What is the rule that we need to use? Yeah, we can use f dash x over fx. Because you can see 1 plus x square differentiation is 2x, right? So all I'm missing is a 2 here. If the f dash x, then to compensate that, I'll put a half in front. So half times ln 1 plus x square plus c. So this is the integration of what? Arctan x with respect to x. This is the integration of arctan x with respect to x. And then have they given us any limits? No, part B, hence show that. So that's the part B. Okay, I got the part A, show that. So moving to part B, in part B, they say to hence show that arctan x in between -1 and √3, right? So basically, we have the answer on the top. All I need to do is apply the limits to that guy. So x times arctan x minus half times ln 1 plus x square. The limits are from -1 to √3. So input the values here, we get √3 times arctan √3 minus half ln 1 plus √3 square. Shall I directly write it as 3? It's x square, so √3 square is 3. So this is the first limit. Compulsory minus in the middle, put -1, we get -1 arctan -1 minus half ln 1 plus x square is -1 square. -1 square shall I directly write as +1? Saves us time, right? Okay, arctan √3, I think we can get an exact answer. What is arctan √3? Pi over 3, right? Minus half ln 3 plus 1 is 4. Minus arctan -1. Minus pi over 4. So minus arctan -1 is plus pi over 4, right? Minus half ln 2. Is that okay? So we end up getting here pi 3 over 3 minus half ln 4 minus pi over 4 minus half ln 2. Is this some kind of a show then? Yeah, there's a show that half ln 2 and the other terms in pi, they have taken together with the common denominator 12. Okay, so let's get them together. Pi √3 over 3 minus pi over 4. I think they show that we had ln 2, right? There were no ln 4s. So how do I get rid of the deal with the ln 4 I have here? Ln 4 is 2 to the power 2. Then I have minus half ln 2 here. Take the common denominator, 3 and 4 common denominator is 12. Do you agree? So this guy multiplies with 4. This guy multiplies with 3. So I get here 4√3 pi minus 3 pi. Is that okay? Here minus the 2 comes in front, right? Half and 2 multiplies to give you minus ln 2 minus half ln 2. So minus 1 ln 2 minus half ln 2, you can add. How much do we get? Did I do any Take. Ah, yeah, the minus should be plus here, right? This minus into this is a plus. So this is a plus. This is a plus. So 1 minus 1 ln2 plus half ln2 is minus half ln2, right? And I can take a pi out from here. 4 root 3 minus 3 times pi over 12 minus 1 ln2 plus half ln2 is minus half ln2. Is this to show that? 4 root 3 minus 3 over 12 pi minus half ln2. This is our show that. Okay, moving on to part C. Part C, the curve C has equation y equal 2 arc tan x. Okay, so that is basically the same thing here, just that there's a 2. The region R is enclosed by the curve, the y-axis, the line y equal pi and the line x equal 3. Find the area of R, giving your answer to 3 significant figures. Okay, once again, what are the limits? The region R is enclosed by the curve, the y-axis, the line y equal pi and the line x equal 3. Okay, how does this work? Okay, so actually when we read like this, we kind of like have no, I mean, it's difficult for us to visualize what's exactly going on. So best thing is you quickly have a sketch of the arc tan x graph in your head. So we know the tan graph is having, we know the tan graph has x asymptotes, right? So then in the arctan graph, all those x asymptotes convert to y asymptotes. Okay, so then the y asymptotes are at the x asymptotes in the tan graph were at pi and minus pi. Sorry, yeah. They were from where to where? And 90, right? Pi over 2 to minus pi over 2. Is that correct? No. Get this properly. Yeah. So for the tan x graph, the asymptotes are at pi over 2 and minus pi over 2 and pi over 2. So when we convert it to arctan, the arctan graph also has the asymptote at pi over 2 and minus pi over 2. However, we have two arctan. So because when we have two arctan, your asymptotes pi over 2 minus pi over 2 multiply with 2. So which means your asymptotes are now at where? Y equal pi and minus pi. The pi over 2 is the original asymptote in the arctan graph because you multiply it with 2. They become pi and minus pi. Okay, and then your graph, the graph was something like this, right? So now what happens? They say the region R is enclosed by the curve, the y-axis. So we have the y-axis, the curve, the line y equal pi. Obviously, the line y equal pi is the asymptote, right? The line y equal pi is the asymptote, and the line x equal 3. So the line x equal 3 is, let's say, it's somewhere over here. Can you see? So these are the limits. So can you see the region that they're talking about, the area? So do you see this is the area they're talking about, the region enclosed between the y-axis, the line x equal 3, and in between y equal pi. Y equal pi, of course, is an asymptote, so regardless. And the x-axis, right? Okay, so then find the region R, find the area of region R. What are our limits? From where to where? From 0 to 3. That's your limit. So how do we find the area? Area of a curve we find by the integration of, we integrate the curve, right? Integration gives us the area. So integration of what is the curve? 2 arc tan x from where to where? 0 to 3. So let's integrate 2. Integration of arc tan x we have already done. So integration of arc tan x, input the answer. Arc tan x answer was x arc tan x arc tan x minus half ln 1 plus x square. The limits are from where? 0 to 3. So input the limits. 2 times, this is 3 arc tan 3 minus half ln 1 plus 3 square is 9, right? Close bracket minus, then input 0. So I think when I input 0, 2 times the x is 0. So basically 0 into this thing is 0 minus half ln 1 plus 0. So I get ln 1. Half ln 1, which is again a 0. Basically this whole thing is just a 0 and it's not needed. So now type the thing in the column, get me the answer. I think we can give it to 3 significant figures. 2 times 3 arctan 3 minus half ln 10. So type the value in the cal. What's the answer that you get? Yeah, so in the question they say the curve has, the region. I think I have taken the region here, identified the region wrong. The region that they are talking about here is, they say the region R is enclosed by the curve, okay, by the curve. So this is the curve. The region R is enclosed by the curve, the y-axis, the line y equal pi. So it's up here, the line y equal pi, and the line x equal 3. So actually they are describing these 4 boundaries, right? They never set the x-axis. We don't have the x-axis as a boundary. So basically the area they are talking about here is this. This is the area we need to find. Okay, so anyway, all I have to do is the area that we found here is required. All we have to do is we need to get the area of the rectangle and subtract it. What was the area you found here? 5.1916. Okay, 5.1916. Now what we do is to get the area we require, get the area of the rectangle. So what's the rectangle? Area of the rectangle is length into breadth 3 into pi. So then shaded area or region R, area of R. So from 3 pi, you should subtract the 5.1916. How much is it? 4.23. So this is the area that we need. So you need to read the question carefully and find the region that they are actually talking about. Okay.